that for you in the most user-friendly way, to give you this access to these user models, data models, so that it's just a drag and drop for you to use them in kind of creating a workflow for you and profile the data, create your own services, and create these services really fast. So one of the drivers that you saw was time to market, because today, if you look at it, the needs change and they change really fast. So, for example, we did a POC a couple of months back, and there were 5 vendors who were part of this POC. The first criteria, success criteria for this POC was how fast you could do the POC. So that is one of the key asks of most of the IoT adapters today, because your application needs changes. Today you want this app, tomorrow you want something else, because your business changes, the needs change. So how flexible, how fragile, and how fast, how helpful this application, the platform is in creating those applications is very, very critical, right? So that's our key strength in enabling you to give access to those data models and creating those services and workflows. And apart from that, it gives you a lot of built-in templates in terms of ready templates to use for integrations and for other aspects, for security. For example, you want to integrate the AD for user profiling. There's an AD connector or interface with a specific database or interface with a specific applications. So a lot of these connectors are readily available, so that you could use those connectors, which will help you to connect with the backend enterprise applications that I talked about, right? Yeah, maybe add a layer of security, add a layer of LDAP or whatever user profiling data. So that becomes a very easy and a nice approach to kind of pull that thing, drag and drop, create your services really fast. So for us, we don't have any problem in operating in any of these cloud providers. Which will use their infrastructure as a service to host our platform. So some of these components would vary a little bit, but basically the fundamental building blocks for any cloud providers remains the same. They have this ingestion where message queuing, your data modeling and the database, which is finally used for your data sources, and then the rest is your proprietary tool. That's where the concept comes in. After all that, the data is fed, and then we use that data for the rest of the things in terms of service creation, service modeling, profiling, and user modeling and analytics. So we are completely agnostic to the cloud that is available. We are absolutely fine with what is there, and use that as a platform for running the services. So some of these things as an orchestration. The first one that you see is bubbles all over is the service orchestration dashboard that you see, where I spoke about creating that service really fast, where you can drag and drop those components. To the left, you see the components that are available readily, 200 plus components for you to create those services really fast. The charts, the web available for your dashboards, where you choose what you want, drag and drop, create those representation. So every IoT story, at least 6 to 8 of 10 that we interface with, has a story of your field force management. So IoT story is incomplete without connecting to the last mile field force. So there are people who are the last mile interface for these IoT services. For example, if you're running an IoT for telematics or heavy machinery, there is a service person who is the last mile field force for rectifying that machine if it's gone wrong, right? So location tracking, field force management, it becomes a composite part of your IoT ecosystem, where you understand where these service engineers are on the field, what is their location, where they are currently there, and based on their location, you can allocate a ticket to them. For example, there is an engineer who is currently in a specific location, and there is a second problem that has arrived for a specific IoT enabled machine, and he's the best guy. You can enable that guy with a second call, so that he's already there, he's at the nearest proximity, he's at the best skilled person to take care of that. So you're enabling him with the second ticket, so he'll address that and come back. And while he's doing so, you track the entire audit trail in terms of when he went, what is the route that he took, was it optimal, and did he really go there, did he close the ticket? So entire field tracking mechanism becomes a very critical component of most of the IoT solutions. So now I'll spend some time quickly on some of the use cases that we developed, some of the success that we have seen. So, this is one of our first success that we see with this railway system. So he's a third-party provider. What he has done here is, this story is in US and UK. What he has done here is, he has white-labeled this service as J&J system, right, taking our service. So he's monitoring this heavy machineries which are remotely on the field. These are diggers, cranes, heavy machineries, right? So what he's doing is he's monitoring the systems for critical metrics, and this is monitored through satellite Canvas protocol. These machines have telematics sensors which we collect critical metrics of the machine. So you actually know how are the critical things performing in the machine. Now, what we also do is, while we are doing so, this data is transmitted, and he's actually monetizing this in many ways. So what he does is, if there is a problem in one of the machines, right, he sends an alert to the service vendor. So for each alert that he's sending to the service vendor, he's charging the service vendor, because that's a business to the service vendor, because he comes back and he'll charge back to the customer. So that is the way he's monetizing it today, right? So he has created those services. He has got a complete vendor list. He sells this data to JCB. For example, JCB is the manufacturer of this heavy machine. Now he's selling this data that he's collected to JCB itself to tell them, look, this is how your machine is performing in terms of telematics, right? And this is how it is actually performing in field, so that they could use this data to optimize their engineering, right? Because how the machine performs on the field is a very relevant data for them to optimize and engineer their devices much better, right? He would sell this data for insurance. For example, he knows exactly this specific heavy machinery the insurance expires in the month of August. So that, look, go talk to this guy, he's going to renew his contract, right? So there are n number of use cases for which he's using this to monetize that and alert, notify, and digitize the whole system. So these they also are assigned customer as a reference, because they are very happy with using the services. And the other use case is smart community. It could be a huge apartment complex where you can automate a lot of things within that smart community in terms of water level monitoring, to automate your compound, automate your lighting based on the conditions outside, automation of switching on, switching off AC, right? Automate your vendor management system, tap leakage, water leakage. So there are n number of use cases around that in terms of smart community. So this is something that we are doing in US, which is smart agri, where smart farming, where we are looking at this. We are integrating with few of the Intel components from the sensor gateway side, where we are monitoring some of the very critical metrics in terms of soil moisture and other texture, in terms of the weather conditions, based on which we arrive and notify certain critical information. For example, if you start watering in the morning and if you have a forecast that it's going to rain heavy in the evening, you can notify those people saying that you don't have to do that, because there's definitely a rain which is possibility of 90%, right? So based on the soil conditions and measurements, and few of the other metrics, you know that what is the best fertilizer for these conditions. And this varies based on the area, region, the type of soil, and many other metrics. And then you go back to the dealer and notify that this is the kind of fertilizer which is the best fit, so that for holistically you get from a geographic perspective what is that best suits for this area, and maybe help dealer in managing that supply chain for that. Some of the other use cases we have done, we have ready solutions on tower monitoring. Tower monitoring is very active use case that we are taking into the market today. There are a lot of tower infrastructures that you see, and there is a lot of complexities behind it, especially in Indian context. If I have to say, these tower infrastructure are owned by company A, and they are used by the operators. And operators pay to the infrastructure providers against very strict SLAs, so that the tower infrastructure guys make sure that they're powered, they're running up and for 99.99% availability. So the need of IoT here is that making sure what is the level of fuel that is in the generator, right? There's a tower center, which is a small room below the tower normally, where there are critical components placed, and to understand what is the temperature in the room, because it should be the optimal level, because these critical components above 40 degrees might collapse, right? So utility billing. So there is a single source of AC current, DG current, and battery input goes to the system SNPS, and then it distributes to different split for each of the operators. So earlier there was no way for this tower infrastructure providers to understand what is the consumption by Airtel operator or Idea operator or someone else. So now you clearly understand, because of the sensors at the right point. So Airtel has used so much of current, I should charge him so much, right? So that's another use case. There are a number of use cases like that. For example, who has come in and gone out? There are door sensors to know that somebody has come in and somebody has walked out. Now the door is closed, right? Likewise, you know exactly last 1 month how long your generator was on, right? Based on which the person who went there and filled the fuel, because many a times it's a big leak there. Many a times you are not sure, did you really fill 100 liters in this specific location? You don't have any way to measure it, right? There are some very specific telco specific use cases also. So this is something that we put up recently because this is a case that is currently being run, and it is really matured to a good level. So that's why it has come on the slide. We met a telco customer, and then he said, "You're a little late. You know, we already have a platform. We have invested heavily on that." Okay, so it was a very difficult start for us. Then we still started discussing with him and said, okay, you have a platform, but then there are other things that you need to do with the platform. Basically, the monetization is a critical aspect, and how well you can create the services and applications. So he said, okay, this is what has been told. But then what we did was, in that process of, we enabled him how easy to create the services, how easy to create the application, because that's the most critical part of your IoT story when you really want to monetize it. Because there are 250 platforms today to collect the data and represent it. That's not all about IoT. IoT doesn't stop there, it just starts there. Your data modeling, data representation is not IoT. IoT starts after that, creating those services really quickly, really fast. How I can create those services, how agile you are connecting to different infrastructure components, how you can reuse those components, right? And you have a complete partner onboarding, because this is a very common ask when people are really looking seriously at IoT, is how you can commercialize that. Do you have a commercially viable onboarding model for your partners, SLAs, security aligned to that? So that is a very critical component. And if you look at any telco, right, when you talk about what we positioned in this telco is, we said, okay, you already have a platform, I will act as an API hub. On above the platform that you have to consume those data models, and then connect back to your DevOps, because there's a huge activity on the DevOps side in telco, which they're developing new applications, data feed to the DevOps applications to test sample data and a lot of other use case testing, right? And go back to the enterprise applications that they have to see those test cases, interface with the partners, vendors. So there are enhanced services that can be expanded beyond a typical device connectivity story. Healthcare, I spoke about it in a gist, but then there are a lot of use cases, especially in healthcare, and there's a lot of focus on healthcare. Having said so, there are some difficult situations also in healthcare that we face, which I would like to share is that somebody said, yeah, okay, we can try IoT. We want to see how my devices in ICU would work. But what happens there is, once you go there, there are these Philips machines, Siemens machines, something else there, and they have a COM port which is supposed to give the data. Most of the times it's dummy. Or you call up the Siemens guys, they say that to enable that, this is the additional cost. So those are some of the challenges that you have still on the device side, especially in healthcare. But then there are other use cases in healthcare, which I talked about: patient monitoring, patient retention. For example, your IoT has an application which will enable you to notify someone saying that, look, at 6 o'clock you have a doctor's meeting, right? And then if you don't go today, enable him, notify him, send him reminders, make sure that he comes back, interface with the doctor, right? Application for the doctor itself. Doctor walks in, these are consulting doctor who walks in a big hospital. He is already alerted that today he has to go to second floor, third room, and he has got 20 patients, these are the patients. And the next thing he knows, everything is automated in terms of application. So this is how the industry is evolving in terms of healthcare, right? Today, for example, you have a checkup, which is a full body checkup, for which you take some 10 tests. So now there's a sequence of tests, and where you go to a test and you see that there are 20 people standing in front of you. Now, with an application which will help you to tell that, look, there is another test that you could do for which there are only 3 people waiting. So just as a simple thing, right? There are so many things like this, even in healthcare, that we are working with one of the system integrators back who is focusing typically on healthcare on the application side development, and also enabling that how they can bring up the efficiency in the whole IoT ecosystem. Solid waste management is something that we are doing typically from a smart city perspective in India, and where we are looking at dustbins which are notifying them whether it is full, and if it's full, then it has to be notified, and using an RFID, where the garbage truck comes and it has picked up, and where is the truck? Is the truck taking the right route for its destination? If the truck has not taken, notify the truck to make sure that these bins are cleared. Right, it's a complete smart vehicle tracking system, including the garbage. So this is what quickly I had. I exactly took the time that was given, 45 minutes 37 seconds. So if we have time for questions, I'll be more than happy to do so. Any questions? So we'll be here. If we don't have any questions, we'll be more than happy. Our colleagues are here. I'll be here for some more time. So thanks a lot. Thanks for your time once again.
Thank you, Mr. Manjunatha, for sharing your valuable knowledge with our IoTers. Indeed, it will be valuable for us. Next session is dedicated for someone who has published an IoT white paper, which has been presented in international forum as well. The focus of the session will be service-oriented innovative IoT network infrastructure. So let me cordially invite our second guest speaker, Dr. Janaka Vijaykorn, Senior Lecturer of Faculty of Computing of SLIC. Thank you.
Very good evening. Hope you all can hear me, right? Very good. So, first of all, let me give a brief introduction about myself. I'm Janak Vijayapon. So, I recently got my PhD from K University, Japan. And currently, I'm affiliated affiliated with Department of Information System Engineering, Faculty of Computer University, Sri Lanka, as a senior lecturer. Apart of that one, I'm a researcher, visiting researcher for the Laboratory Department of System Design Engineering, K University, where I got my PhD, and I'm currently working for them. The work that I'm going to present to you today is kind of work that I was involved with about last 6 years. I totally agree with the previous presentation, and believe me, it is quite funny. When in 2011, actually, I wanted to publish a paper about those collaborative platforms and collaborative applications. And when I submit that paper, the paper was rejected, saying that this is too futuristic. Today, after 6 years, we are having those applications with collaborations and platforms with collaborations, and just now we are talking about those things. And today, what I'm going to present you is the research work we have done during 6 years, and he's our supervisor, Professor Hiroaki Nishi, and our laboratory consisted of 2 research groups. One is smart community application development, which is very similar to IoT application development as we talk here, and the other one is smart community network infrastructure development, which we are looking at the IoT network or IoT applications in a different perspective from the network. So in smart community applications, yes, we have some experience from 2011. We have done lots of projects in Nagasaki Prefecture, Kurihara Prefecture, and universities, including my university, K University, Tokyo University, and currently we are making IoT community or community infrastructure in using Uram project. Apart that one, since I'm interested in networking, I actually involved in the not IoT development part, application development part. I involved with the IoT network part to look at the IoT applications or IoT infrastructure from the networking perspective. So what I have been focusing for last 6 years was service-oriented router, service-oriented network, service-based open innovative platform, and developing some common API to do collaboration among applications as well as some hardware devices. That's why I said that I totally agree with the previous speaker, because we are talking such things from 2010, 2011, and just now those things are getting into the big picture. So this is my crew actually last 6 years, led by Professor Hiroaki, Dr. Ishida, and myself. I'm going with Jana, so you all can say me Jana if you like to. Tatsuki Miura and Kenichi Takagiwa, and I'm really proud that there are 2 Sri Lankans with us to develop the platform what we are talking here today, Rajita and Shanagar from Sri and Katogadda consecutively. Well, so if you think about the jargon, we always talk about IoT, Internet of Everything, where it comes persons, data, and people, things, everything is there, identity of things, edge computing, cloud computing. Cisco says edge computing is a fog computing, and yes, everything is there. They are trying to manage ourselves, and they are trying to give some smart services for us. However, someone might say something like this: internet switch, come on, hello. I don't want the CI sending me advertisement for my mail. Yes, That kind of criticisms are also there. However, according to the statistics, it was stated that half of the world population on 2013 centralized into cities. And it is predicted that by 2020, half of the population of Asia Pacific or Asia will move into cities by 2020. And the density of cities will grow from 3.6 billion to 6.3 billion. So we, as a laboratory who are doing networking infrastructures and IoT, we thought that, okay, the cities should be smart. The community should be smart enough to provide some solutions to these services. Housing, pollution, water, energy, education, traffic, wealth and well-being, crime. So this, as a community, as a city or as a community, the towns or houses and the entire community has to be smart enough to handle these services with an automated manner. Very well. So we looked at the big picture like this. We understood that there are some devices and there are some cities. So from devices to cities, we can provide different services. From devices to cities, there are personal areas and home areas, town areas and city areas according to the area, according to the geographical location, as well as the network topological information. The services has to be different, as well as the services has to be smart. So our main target of the project is to develop a collaborative platform among these from the device area to the city area to negotiate among themselves and provide some services. Very well. We understood that the common ICT infrastructure with the IoT networks, they provide these sort of services. The services listed here. ICT network is there, and the telecommunication network is there, electrical network, and as mentioned in the previous presentation, soil and everything is there. But every data is centralized into a data center, which we basically known as cloud. However, our motivation is not to get used to cloud, but to develop applications from the area itself, from the geographical location itself. So we need a common API, and we named it as service-oriented platform. So using service-oriented platform, we were looking at environmental business. We can sell data, we can aggregate data, we can aggregate services, and we can do data mining as well as recommendation services and provide smart services from the user's perspective. Okay, let me take one example. Can you all do me a favor? Is it okay that I ask you a favor? Can you all take your mobile phones out? Please, if you have a mobile phone, can you please take your mobile phones out and like display, show it to me? How many of you take your mobile phones? Is it your mobile phone? Is it a smartphone, isn't it? Why do we say it is the definition of the smartphone. Definition of the mobile phone is just a simple device which we can do talking. But when it comes to smartphone, the mobile phone is just merely a simple feature, isn't it? So that's how the world is evolving. Why then? How the mobile phone is getting smarter and intelligent? Well, actually, I had a very funny experience today. I didn't have my vehicle today, so then about 2:30, my phone said me that you have an event today. So the Google event calendar just displayed me, okay, you have an event today, and I was wondering, it says IoT for everyone 7th Colombo IoT Meetup. So I didn't add that title. I just add to my calendar IoT Meetup. That's it. But I was wondering how it is a very descriptive event. It is actually the title of the event. So I was wondering how that calendar knows about my title, about the exact title of the IoT Meetup. Then I understood that, yes, I added the Meetup application. So the Google Calendar was synchronized with the Meetup application. That's how the Google Calendar became smart. Then Google Calendar suggested me, okay, do you need the location to go to IoT Meetup? And then I said yes, and since my vehicle is not there, it suggested me, why don't you take Uber? Then Uber, when I looked at the Uber just gave me the route, fare information, everything. How all these applications of our smartphone take the data, the information. The secret behind that one is a collaboration platform. The operating system is working as a collaboration platform. So we inspired by that idea, and we actually wanted to make a collaboration platform for information sharing in the IoT network. So we presented this collaboration platform for IoT devices, including routers, servers, gateways, line terminal equipment, to make a collaboration platform by presenting it to ITUT work group. I hope you all know about ITUT work group. So we proposed one work group for ITUT, and yes, now it is actually happening there. And according to ITUT work group, the platform was known as ICT Life Infrastructure Service Interface. That service interface, as I'm very sure, sorry, the diagram is not that much clear. So according to the diagram, it takes all the data from different sources: cities, houses, government, weather data, electricity data, grid data, vehicular data, everything, and they insert it into a common database known as ICT Life Infrastructure Database. So then that data will be anonymized and like reproduced to get to an understandable format, and let service providers to let the data to taken by service providers to provide some services according to the geographical location as well as the necessity. Then, as I said to you previously, the data is everywhere. Sensor devices are there, gateways are there, routers, switches, and like servers are there. We can take and collect data from all of these things, and we can provide smart community. We can provide services to make smart community from devices to city itself without a barrier. So always we do not need to go to cloud, take data and do some manipulation and provide some services. No, it is not the case in the future. Always they can take data, the application developers can take data from sensors, gateways, switches, routers, servers, or the infrastructure and develop their services according to the necessity of the service. We can make services much more smarter, not standalone services. Then, actually, we presented this one in the IEEE Smart Grid Vision for Vehicular Technology. We actually, the time we were proposing this one, we named it to 2030 and beyond. But now, actually, it is there. So now, actually, we are like updating the proposal to IEEE Smart Grid Vehicular System to do some novel tasks using collaborated architecture. There, actually, what we demonstrated them is HEMS and BEMS system, home energy management and building energy management system with vehicular systems to exchange information from one smart community to another smart community. There, actually, we did some demonstration to like give electric vehicles to charging quota. The vehicle from one smart community charged its battery, and when it moves to another smart community, the loan was like applied to that smart community. So the batteries were, the energy was loan for smart vehicles, as well as baggage systems and garbage systems, electricity systems were implemented in Japan using this proposed smart grid vision system. Then the main problem actually we came up with how we make the routers, gateways, line terminal equipments, and all other devices intelligent. Do they have a platform to do development? Routers are merely some devices which do some packet switching. So how they become smarter? To do that one, we propose some ASCA or deep packet inspection feature to routers to make them smarter like our mobile phones. Then the routers will not just route data, and it provides some services. The router we actually implemented is known as service-oriented router or smart community router. It is a cutting-edge router which can analyze the content of some data streams and store those data into database, which is known as community database, and use those data, aggregate those data to provide applications according to the necessity, according to the requirement of the user. The generation 1 service-oriented router was implemented using libpcat and C++ libraries, and only throughput we were achieved was 2 Gbps. But we understood that no, the networks are evolving. It is going beyond 100 Gbps. So we shifted with Intel technologies, Intel DPDK, Xeon 5 processors, hyperscan technology, and quick access technology to achieve more than 40 Gbps at the moment without a single packet drop. So the routers are getting smarter now. It can provide services, a part of the routing service. So then we were lucky enough to demonstrate our system of one of the world's biggest showcase, shown in 2017, and service-oriented router was working pretty fine to cluster data, analyze data, and show the browsing history of the entire network, and it was working fine. So with confidence, we introduced the Docker technology as well as zero copy technology to the SOR, so that the services platforms can be developed in the router itself. So it doesn't matter it is a HEM system or edge computing system or cloud, the application developers can go anywhere and develop their application and migrate application with supporting of information sharing, platform sharing, process sharing, and service migration, service aggregation, and service integration. So the developers are not caged into one particular cloud to do their developments. They can go all around the world, all around the network, do their services according to the requirements of the users. Then this is the actual architecture we were implemented. According to the architecture, the Docker container management layer was the intelligent layer or the common platform, which talks with other routers and do the service migration as well. Then this is how the services can be registered according to our system. And I'm not going to explain these things in detail. So if you have interest about these systems, yeah, I can do some explanation in detail. And the project is still continuing to do some service migration. It means like one particular application developer develops some application in home gateway, and when he needs to move that service into line terminal equipment, yes, we are supporting him to like totally move the service itself to the line terminal equipment using the support of Docker, Git, and some other technologies such as zero copy technology. Then our system was achieved about like 40 Gbps throughput, so this router can work up to 40 Gbps and then provide some services without any single data drop, and provide some platform for the development. And as I said you previously, we used Intel Xeon 5 processors, and we were successfully pushed Intel Xeon 5 processors to work as SORs and to achieve about like 3 teraflops. So for big data analysis and provide services using data analysis technologies, yes, we successfully used Intel Xeon 5 processors to implement the service-oriented router. So using those implementations, we developed some projects for Japanese government. For some, this is a project we created in Nagasaki Prefecture for city to make a smart community using city library and community hall and hospitals, and we collect all those data and we develop some services and introduce our service-oriented network platform for those infrastructures to make some smart services. Then these are, I don't know whether these figures are clear enough to you, and this is we are monitoring some control systems in Kurihara City Hall to provide some electrical control systems, which is AC and fans and light control. And this is one electrical management system where we can take some electricity from one microgrid to another microgrid. We can lend electricity, we can hire electricity, and we can loan some electricity data, not data electricity from one microgrid to another microgrid according to the user requirements. And these are the sensors and these are the monitoring tools we use to implement those IoT networks. And this network was created in Nagasaki Prefecture to use that community database, community or smart infrastructure in the community database to navigate persons. According to the electricity consumption of a particular vehicle, they navigate according to the tourist sites, and they give some smart services to the car dashboard according to the information that we have, electricity information, tourist information, traffic information, as well as the user requirements. And we created a zero emission house which does not emit any bad rays according to our definition. And the zero emission house is totally based on IoT networks. It controls by the IoT network. Power is controlled by IoT networks. Electricity system controlled by IoT networks. And the how to say AC as well as heating systems and parking systems, everything is controlled by the IoT networks. And I'm very sorry if these figures are not like clear enough. This is how we implemented the IoT that collaboration platform for using our collaboration platform, the IoT networks. And we also implemented some campus system to receive electric power data and co-generate systems with the power data according in like 3 campuses which is situated in our perimeter. And these points indicate that these are the places we manage the data, and this is the place actually we receive electrical power data. And using these red dots, we use our smart system to like negotiate power data and like exchange power data among our universities. Then with the vision of creating smart community global market for 10 trillion by 2020, our smart community network platform will be evolving from community sensing to new community data sensing with the help of feedback of the quality of living improvement for human-oriented service providing. So that's actually what I was publishing in the paper, which is introduced by the introducer. So that's end of my presentation. Before that one, this is the I'm sorry that this is that Intel Xeon 5 processor, which is processing in like 272 cores to do that kind of like 3 teraflops processing. So this is the end of my talk here. And if you have any questions, I'm really willing to answer you, or you can directly send questions to my email address here, and I'm available in Skype also. So if you have questions, just shoot at me. Yeah. Sorry.
Yeah, it's about you were mentioning about fog computing.
Yeah.
So and also there's this another word for computing. Sorry.
Edge computing.
Yeah. What are the differences?
Fog computing, in basics, fog computing is the interpretation of edge computing from system.
So it's okay. Then what I mean, without going to cloud, say if I mean IoT usually generates a very huge amount of data. So how do we kind of store the how are you going to store the data when you are kind of entirely on for computing?
Yeah, that's why I said like we were introducing some distributed database known as smart community database here. In our proposal, we introduce this database infrastructure with a distributed manner. So each and every service-oriented router we place in the edge has its own database. So we tested the databases are working. Have you ever heard NoSQL databases?
Yeah.
Yes, we use NoSQL databases like key value stores and stuff to make it like so faster. So each and every SOR in the network just contains those distributed databases. So the Xeon 5 machine, what I was talking about previously, it has about like 192 GB memory. So that was enough for day-to-day management. I'm not saying that we are not uploading data to the cloud. Yeah, of course we are uploading data to cloud, but to provide services from itself, we just maintain the data.
And also the message processing. So events processing.
Yeah.
That's also done from
the edges perspective. Yes, that's why I said like the big data analysis, and that's why that is the reason we mainly shift into the Intel Xeon 5 because it is the master.
So, I mean, did you write your own platform for this purpose? Or
Yes.
That's cool. Okay.
This is the platform which like we are implementing at the moment.
Yeah. Thanks.
Any questions? So, may I have my presentation now? Okay, cool. Thank you very much.
Thank you, Dr. Janaka. It was indeed great listening to you. Next two sessions are dedicated for two demos. Friends, what if I tell you that we can power up IoT with magic? The next demo is all about that. Powering IoT with magic by Director of Technology of AT Labs, Mr. Anuruddha Tennakoon. Mr. Anuruddha, this invite is for you to proceed. Do we have Mr. Anuruddha? Okay.
Good evening, everyone. I am Dilip from Magic.io. We are a startup company working under the IoT and hardware area. To begin with, let's start from an example. In here, it's a simple house automation application where you talk to your mobile phone and turn on the light of a room. So, thinking about the complexity of such kind of projects, to start with a hobbyist or a general person, they need to have been good for hardware, where you need to buy a small Wi-Fi device or any communication device, connect it to a relay to drive the light, and to get the power source to power them up is one side, and sending all the replies to messages coming from the internet and connecting that part is another edge of programming. And then from the mobile phone perspective, either you have to develop an app or to purchase that and to connect them to the cloud. So in the later of this flow, we'll show how these things very easy by using magic blocks. So as for the second example, let's think about a warehouse where there's a possibility of gas leakage, and then there can be a message generated for your mobile phone for the security purposes to indicate that there's a gas leakage. So again, for that kind of application, you have to integrate a gas sensor. Generally, gas sensor consists of an analog output, so you have to do analog to digital conversion process, and then to threshold it, and then from that decision taken, you have to send the message to the mobile phone. So this kind of a flow, magic block by using magic blocks can be developed within a few minutes. In here, we can show you how easy to do a similar thing using magic blocks. In this case, we will show to develop a flame detector where it can be connected to a siren and how fast we can do it. So the first thing we do is we get a time trigger. We connect that time triggering block, and then we connect it to a Wi-Fi module or a module we can take the input from there. So the hardware designed to take this is a ESP12 based Wi-Fi module, and for that we have connected a flame sensor, and then the digital output taken from that, and we are now connecting it into another Wi-Fi module which is connected to a relay module, and that relay is connected to siren. In this case, it will be a bulb. And then once we deploy it, within that amount of small time, you can develop the picture. So till this Wi-Fi device getting connected to the internet, I am reading this presentation. So we started in 2014 as a startup company who works on the microcontroller development platform. So we developed a generic microcontroller platform which can connect several brands of microcontrollers. For example, CPIC microcontrollers, ML microcontrollers into one peripheral board. And then later on we move on to the communication areas, and we develop communication boards like Wi-Fi modules, GSM, GPRS modules, and so on. And in the following year, back in 2016, we came to the IoT area. And from that, we developed this magic platform which connect the hardware into the IoT layer. And from that, we designed automatic weather stations and also robotics which are connected to the IoT space. And in this year, we came to another turning point where we start to work on the industrial applications. So in many cases, many development boards are to work with the in this normal standard environment, but in industrial environment there are noises and power surges, static noises and so on. So we design more specialized hardware to interact in the industrial area, get the data or to activate things and connect it into the magic blocks. So where others can do the data communication through that. And at the same time, our company, we do the PCB design services, complete designing projects, and now we are starting a project on automatic AGVs and so on. So these are set of clients. Currently, we are working with Mobitel, MAS, IET, Depo, University of Morocco, and so on. In some, we do the design services from them, and some we are providing the development boards, development platform, IoT platform, and so on. If I speak about why we need magic blocks, when dealing with IoT and the hardware, we face several problems. One major problem is there are a set of hardware vendors and set of different protocols to connect to the IoT. So what we try to do is to bring them all to a single place. So initially our target is to, if any hardware has a serial code, we can bring those data which are sent from the serial data to our cloud platform. And later on we customize our interfaces so that we can send messages and get the information from them. And then the next issue is how to manage the device, whether to look if the device is active or not, or it's just any failure. So again, we have a different interface to monitor the device status, whether it's connected, activated or not. And then our next question is to do the coding work. Like for someone to develop a platform or application, he need to do more coding. So in our flow, we omitted the coding part. So much more is the drag and drop manner, and if needed, they can code what they need. And we are also released some APIs so that they can directly connect to the hardware without using this flow kind of manner to do their applications. So when we talk about the magic blocks, it's completely a web platform which is connected to hardware, and between them we have this industrial controllers, robotic development kits, multi-architectural boards, and so on. And in the cloud platform, we have this device manager, dashboards, and visualization and all. Together, we deliver a seamless and easy programming platform to you all. So Magic Blocks is mainly targeted for each and everyone who want to do something new. So say someone who have no idea about the electronics or the IoT, so he can just take hardware, connect, log into the web platform, and then quickly connect the block diagram blocks to connect his logic, and can do their work. And the hobbyist also can do the same thing. And if you think about a developer where he want to prove his concept to an investor, maybe to do such a project might take months. But using this Magic Block platform, he can do it within a week or two and show it to an investor or their top level and get the approval of the project and for the budget and so on. We can move for the development. In many cases, in our pilot projects, we use the same criteria to run them. So the Magic Blocks consist of playground where we do this kind of logic building, a dashboard where we use to do the data visualization, and we have several mobile apps to interact with mobile data or the user interactions, and then we have this device manager which manages the multiple hardware and hardware. The hardware can be either designed by ourselves, or it can be Raspberry Pi or say ARM processor-based Beagle One rack and so on. So in the Magic Blocks or the AMD Lab hardware offering, we have mainly microcontroller development boards. They are it's a generic hardware platform which designed to use with say TI, STM, then PIC and AppNet. For this board kind of thing, these kind of microcontrollers can be directly plugged and it can be used as a different development board. And then we have our robotic development platforms. One is this mobile robot. It's a differential drive robot. It can be either controlled from the normal usual Arduino coding or from internet using magic blocks or by Bluetooth. And then we have our advanced microcontroller development board. It's for more advanced features like more servo motor controlling, more motor handling and so on. And then we have our IoT development boards. We have our basic building block called Magic Wi-Fi. It's a Wi-Fi module, has basic interfaces. And then we have this Magic Relay. It's a single unit which consists of a relay module connected to a Wi-Fi module. And from that, it can accept our commands and drive light, silent or something. The first demonstration we use this similar module, which is only consists of this relay and Wi-Fi module. And then we have this IoT-based industrial controllers, IoT module, and IoT Lite. The Icon Lite module is for the indoor use, for more light applications, because in some applications they do not need much more security concerns. So it's much lower cost and easy to handle. And then for the rugged environment, for example, say outdoor weather station, it can be done by this Icon industrial control. It has this solar power charging, internal battery, and battery management, and it will communicate with the server within configured, which can be configured without like remotely from Magic Blocks. And it has the ESD protection or the surge protection, all this protection it required. So it's the industrial control. This automatic weather station we designed is based on this industrial control. What differs it from the generic weather station in the market is, in the general weather station, it's only have this rain, temperature and humidity, then wind direction, wind speed and pressure. But in our design, since this our Icon controller can accept or handle many devices, those apart from those basic sensors, you can include like tilt sensors or maybe geophones or maybe water level sensors. Anything you can need it can be easily integrated, and from that drag and drop without writing any code, you can access it. So this is our the cloud platform where we connect them, and from there we have basic APIs for advanced functionalities like image processing, stream analysis. And since this is a visual programming thing, it's not much complicated in handling. So in this platform, this is one of the major parts, the device manager. In here, we can add our hardware, and each hardware will have its device ID and a key, and we can give it name. And then once we connected this, it will show whether the device is active or not, and then we can modify the device, and whether if we need, we can remove the device. And then the second part is the Magic Blocks playground, where we develop our logic. In here, in the left side corner, if you can see, there's these building blocks, input, output, functions, and so on. From each, these building blocks can be either used as a trigger or a signal input or signal output or a stream. And from that, by connecting these blocks, we can build a logic as shown in this one. So this flow is work as a single program which connected your hardware to cloud platform. And then the next problem we have someone having is to visualize the data you retrieve. So we have this Magic Blocks dashboard which can show the maps, graphs, maybe bar graphs or indicators. So you can develop customized visualization aids for your projects. And then for some developers, they they need to do some processing in, say, in a different background, they can use Magic API. So in these APIs, we give different hardware accesses uh, for the coders. So they can like to use API, they can really separate that from the admin edge of Magic Blocks, and then from that key they receive, they can access this hardware. And for the MQTT data transmission protocol, we found that two good applications which can be integrated easily to the Magic Blocks. So the demonstration we initially showed also contains one MQTT mobile app. These apps can easily interact with the device sensors and they can send MQTT format data to the Magic Blocks. From that, we have the MQTT decoding block in the Magic Blocks playground. From that, you can retrieve the data and activate the data on the data flow whatever you need. So that's all about Magic Blocks. We have a Magic Blocks blog.magicblocks.io where we have the instructions. So that's all for us. So if you have any questions? Magic Blocks runs on the server, so we have the inner server capability. What we have done is we are not running the entire code of the hardware. We are just sending a message and taking reply to it. From that, then we go to pursuing the cloud. So the cloud person call is nothing more.
Gateway, do you have any extra cover that you can run some basic Java application or something like that? It's on the
So what microcontroller does is microcontroller replies to the server request. So if you need some analog data, server will request the microcontroller to retrieve analog data from a certain pin in a certain device. So it will find that device and get the analog data and send it to the cloud. So the algorithm processing will be done in the cloud. So what the advantage is, say you want to run a image processing application, then to run an image processing application, you have to go for like something like FOC for microcontroller with a higher power. So in this case, what you can do then for the interfacing part, you can use a simple small ESP module. So it will retrieve the data and it will send to the cloud. So cloud has the processing part. In there you can do processing and it send back the user.
How about the average delay?
It's about 100 days.
If we get some like problem or if we get some, I don't know, bug or something, like how we do reporting, like how about the after?
So we have this device manager. Say the device manager displays the connection status, currently connected on. So it's like a heartbeat. So from inside that you can see whether device is down or up. And we also have this debugging interface in the yes, we have debugging. So it's like you can test messages and see how this message is being passed.
Cool.
So we can show that demonstration form. I think still we are having this communication issue. Any questions? Now, but we are trying to simulate this to detect this data and run that. So it's just a now slow. Thank you.
Thank you very much for sharing your experience and valuable knowledge with us. The next demo will be on Aptinex, the IoT maker, and will be done by CEO and co-founder of Aptinex Private Limited, Mr. Chatura Dhananjay Yapa Bandara. Please come forward here.
Hi, everyone. Very good evening to all of you. I'm Shatura from Aptinex Private Limited, and we are a hardware designing and manufacturing company. We design IoT and other related electronic modules, and we do customized projects. Before I go into the IoT approach of Aptinex Private Limited, just give me 2-3 minutes to describe the journey that we came. In 2010, several friends, 4 friends actually, we started a company called Inus Technologies at somewhere in Batharamulla. And at that time, all of us were frustrated with our jobs at time and at that time, and we were thinking of starting our own company, own venture, and it's called Apple. So we decided to quit our jobs and start something on our own. So we started the INX, and we started to develop products and do the projects. And this is the first product that we manufactured. It's a big kit to programmer. I think everyone is know the big microcontrollers, and this is the program that we did. This is totally designed and manufactured by us, and this is a clone. This is a clone of original microchip programmer. But at that time, the original microchip kit to programmer was a little bit expensive, so we decided to design something cheaper. So this is the product, and after that, we designed a set of products and projects for customers, and we had some products on our own. These are done in 2010 and 11, so the technology was much more pretty basic, and these kind of PCBs that we don't do at the moment. And so we basically did projects and products on big microcontrollers, and later we shift to Arduino and Atmel microcontrollers. And after 2 years of Inus Technologies, we decided to start another company with 2 other individuals, and we started Aptinex Private Limited. And in 2013, our sister company, Lankatronics Trading Private Limited, was also formed by the same director. And in at the next Private Limited, our first product was to enhance the PIC to programmer, which we already designed and manufactured. And this is the enhancement one. You can see we have used SMD components, and the PCB is a little bit actually much more advanced. And this is dual layer board. And you can see the enhancement 2. We have made it even smaller than the first one. So this was sold in eBay also, but at the moment this is a kind of a legacy product because now everyone has been shifted to Arduino and other microcontrollers. So this is no longer manufactured. Then we did some projects and products from 2012 for various customers, and we have our own product line at eBay. So we are selling at eBay. These are the designs that we have done. We use Eagle as our PCB designing software. This is a track module. This is also this amplifier. This is a PIC development board for PIC 40-pin microcontrollers. This is a USB to TTL converter, and many of the products are sold in Dunkatronics trading also. This is a price tag. This is the ATS generator controller for Kukudu. And this is a big mini developer board. This is Atman programming USB-SV. This EL-like controller, this amplifier protection, track module again. And this is an IoT project we done for Mars Unicella. Currently, there are 3 prototypes running. It has a casing, and here comes a motor controller. And there are this is a Arduino, which is done by us. This is a water level meter. Okay, basically Aptinix provides services to the customers and the individuals who are needing products design. So we do design electronic projects and products, and we do customize solutions, and we do IoT products and projects, and we sell at eBay, and we do industrial automations. So we do have 3 brands: Lanka PCB, Arduino, and Aptinix IO. And here comes the Aptinix IoT products. We do have 4 product series: Aptinix Relay Node series, and the Track Node series, and LoRa Node series, and LoRa Shield series. Relay Node is actually, you have heard relays used to control devices. So ESP8266 and ESP32 based relay modules and controllers. And we have Track Nodes and LoRa Node, LoRa technology I will describe later. And we have LoRa Shield, which is a shield based product series for Raspberry Pi and Arduino and other famous single board and microcontroller platforms. So basically, if you take a relay node and track node, both of them are ESP8266 based modules, and all of them are MQTT and MDNS supported, and this can be integrated with any Node-RED or MagicBlocks or any other platform. And all of them have GUI for controlling and settings modification. And all of them are designed and manufactured in Sri Lanka. As a policy, we don't manufacture in China. So Relay Node series, if I take it, there are 3 modules at the moment: 4-channel IoT relay module, and single channel, and 4-channel IoT relay module, which is powered. So this is our first IoT device. This is already in eBay. We have at the moment several companies, overseas companies are communicating with us to enhance this and customize this according to their platforms. So these 4-channel microcontrollers, there are 4 relays which you can connect any 4 devices, and ESP266 IoT module. So every one of these modules have this inbuilt UI. You can accessing the inbuilt UI, so you can connect and modify the settings. See, I am showing this. This is the 4-channel IoT powered module that I am demoing. So this is the 4-channel IoT relay module. So comparing the previous one, this has a inbuilt high-link power module, so you can plug it directly to the AC supply, AC 230 or 110. But considering the previous one, you have to supply 5 or 12 volts using an external power supply. So this is the latest one in the relay node series. It just has one single relay, so you can connect to any device, and this is small in form factor. So you can connect any device and control it using the inbuilt GUI or using MQTT. So this is our triac mode series. This is we have used triacs. These triacs are used for switching high-speed loads, and you can switch AC loads, but and also this has a very silent operation. You don't see the flip-flop sound at the relays. The same as relay nodes. And this is the powered version of the triac node. You have a high-link power module inbuilt, so you can plug it directly to the AC main supply. And we have LoRa technology enabled products. LoRa stands for Long Range Low Power Wireless Network Platform for the IoT. Actually, considering the other communication platforms, you can the LoRa technology, using the LoRa technology, you can transmit data long ranges by only using low power. So this is very good for miniaturized battery powered devices, because a LoRa node device the battery power last up to 2 years. So this is used in many countries, and those frequencies are kept free, unlicensed, so you don't need a license to use, but not in Sri Lanka. Many of the other countries keep at least one frequency range free for using this kind of technology to be used. So on top of the LoRa technology, LoRaWAN protocol has been developed by LoRa Alliance. So every standard has to go through LoRa Alliance. So this is the first product which we done using the LoRa technology. This is the LoRa node RN2483A. So we have used the microchip LoRa module RN2483. So using this module, you can transmit up to 15 kilometers with the line of sight, as the datasheet says. So this is a very famous module in the industry, and currently we are selling this in our eBay account, and this has a good response also. So here we have used the USB to PTM module, and this is USB powered, and also we can power this externally using the pin headers in the board. And this is the second, sorry, I forgot to mention one thing. The frequency ranges are 868 MHz and 433 MHz. So this has 2 frequency bands, so you can select either one as you wish. So this is the LoRa node RM2903. This is the frequency of this module is 915 MHz, and the microchip RN2903. This is same as the last module, but except the RN2903. This is only working 915 MHz. This is the smart LoRa node RN2483A. Why I call this smart? Because this in the previous modules we have not integrated any microcontroller, but in this one we have integrated a microcontroller. And this is having the Leonardo bootloader, so you can program this using Arduino, and the chip is Arduino Atmega 32U4. So this, instead of powering this using the USB, you can also use a battery up to 2000 mAh battery, lithium ion battery can be used, and this inbuilt there's a battery charging controller, and you can connect various sensors to the pin headers of the module, and 32U4 can be programmed accordingly. And this is the first product of the LoRa Shield series, and this comes as a Raspberry Pi Shield. You can plug this to the Raspberry Pi, and this can also be programmed using this one. You can program the Raspberry Pi to act as a low-cost LoRa gateway, because at the moment LoRa gateways are a little bit expensive. I think it's about $300 if you get a LoRa gateway. So for a small implementation, you can use this. You can plug this to the Raspberry Pi and program it. At the moment, we are on the testing phase of a LoRa gateway using this. So, as future developments of IoT and other developments of FTX, we are currently working on IoT gateway and LoRa band gateway, and there will be shields for Arduino and other popular single board computers, and there will be a Raspberry Pi related shields for IoT and general purpose applications. And we are doing the feasibility study for a Raspberry Pi robot platform. Well, that concludes my presentation. Thank you very much for you all, and thank you very much for the Colombo IoT team for giving us the chance. Thank you very much. If there are any questions.
What are the features that will be available? How many ports? What type of input ports will be available in it, and what type of microphones will be there, and then with the Wi-Fi and GSM will be supported?
Yeah, at the moment we tested using ESP32, and we are doing it. We are doing the research. Actually, we have not finalized the final outcome, but it will be developed as a kind of energy measurement. So more details actually we have not finalized. We did the testing, and the test went good, and the GSM will be there. That's all I can say at the moment on that.
And then other question is 2843, I think you write smart LoRa device. Now, can we set up a LoRa network in a local area network without actually getting approval from
TRC?
Yeah, TRC.
Well, we did some talking with TRC, but I'm afraid they are not allowed at the moment. So what we do is we test and we ship. We are not giving to the local customers unless they come with the proper approval. So in Sri Lanka, as per the laws, in the current laws, you cannot do anything. As far as my knowledge, maybe I'm wrong, but as far as I know, there's a law that we cannot use anything beyond 100 meters or something. But they do testing. But in legal manner, we can.
Any specific reason why LoRa is actually selected rather than Zigbee, Wi-Fi, and some kind that kind of actually?
Well, at the moment there's a trend for the LoRa, not in Sri Lanka though, and the LoRa, the specialty is the battery power and the distance, because there's kind of a chirp technology or something. So the transmitter will be powered only for sending data, and the other time it will be went idle, if I say in the basic manner. So that's a specialty, so that saves the battery power. And there's an inbuilt security there, rather than the other technologies. The security is, as far as I know, it's good. Actually, they are sharing keys for the application and so on. There's a vast area of the LoRa to be covered. So that's why we choose LoRa. And in the internet, we didn't find much of applications using the RN248 other than the same tech and the manufacturer. So that's why we chose the RN248. Thank you very much.
Chatura, what's the time between you guys deciding on a piece of shield and actually manufacturing that, or actually like
Well, it depends actually because we all are in a kind of I call it the service because we have to provide service to the customers for the because we are not a very big company, so we have to work with the customer projects. So sometimes it gets delayed. Otherwise, if we do the full attention within 2 3 weeks, we get the things done. So after we designing and agreeing on the concept, and we send it to the manufacturer, and there's a delay of around 7 days for PCB. And after that, if the components are here, it's mostly it's 2 weeks. We do it if we fully concentrate on.
one more question. What's your thoughts on this, frequency condition? Like now, if all these shields start like communicating on given frequency, and then when the deployments get more and more complicated.
Well, that's out of my knowledge zone because that should be. I don't think there will be much of a condition because of the LoRa technology, but that frequency thing is really out of my comfort zone.
It's some random thing that.
What sort of project you are involved with and what sort of project you are doing?
Well, apart from the hardware,
Apart from those hardware development, or the PCB board development and stuff?
well, we did some projects for Epic Lanka, and I'm afraid I cannot disclose much of the detail because of the NDAs we are signing. And we have done some things for the labs Eco and Labs International also. We have done a project in the labs Eco. We are doing RF units for the that eco test centers. So every eco test unit has a product of our own. And rather than that, we did some project in Oman. That's it's for the Oman Museum, and the museum has in each showcase of that Oman Museum has a unit done by us for the communicating with the security system. So, and we do some industrial developments, industrial automations for Sri Lanka also. Okay, thank you very much.
Thank you very much, Mr. Chatura, for your time and effort and for sharing your valuable experience with us. Guys, do you have any other questions for our presenters? Any more questions? Okay, seems no questions. Okay, so it's the time to present the tokens of appreciations. For that, let me cordially invite Mr. Kolita Ratwatte, the General Manager of Persistent Systems Lanka Private Limited. have Dr. Janaka at front, please, to accept the token? To present the next token, can we have Mr. Shiham Naufar, Director of Engineering of IoT Products of Persistent Systems Lanka Private Limited? To accept the token, can we have someone from AT Labs, please? Next, let me cordially invite Mr. Shamika Pattinige, Manager of Product Service Innovation of Mobitel. Can we have Mr. Chatura at front, please? Okay, thank you everyone. Next, we do have the vote of thanks by Mr. Sanjay Madansa on behalf of the Colombo IoT Organizers panel. Thank you.
Thanks, Ishaya. Good evening, everybody. So, hope you had a great session and you were able to gather some knowledge on IoT. So, I will quickly thank the organization and people who helped us to make this a success. So, firstly, I would like to thank our sponsors. Without them, I don't think we will be able to make this a success. For this time, also, like previous 6 events, Persistent Lanka Systems was formerly Epona is the main sponsor. And I would like to thank Mr. Paul Saratat, the General Manager, Persistent Lanka System Private Limited, for providing all the support and funding required for the event. And our co-sponsor this time is Mobitel. For the last few IoT events, they have helped us as the communication partner. But this time they have extended their support as our co-sponsor. And I would like to especially thank Mr. Akalanka for coordinating all the activities on behalf of Mobitel for the organizing. Then I would like to thank all the presenters who have shared their valuable experience and knowledge with the fellow IoTers. And Mr. Manjunatha Devadiga, Head of Pre-Sales back in Japan for Sarvat. So he has come all the way from India to have this session with his busy schedule. So I would like to thank him for delivering the main session. And then I would like to thank Dr. Chanak Vijaypur for sharing his research experience with the fellow IoTs. He's a senior lecturer at SLIT. And I would like to thank two demonstrations by AT Labs, Mr. Tiruna Amrahat and Mr. Tatura Japavanda from the Appinex for presenting their products and conducting demo. Then I would like to thank Magicblocks and Lankatronics for providing discount vouchers for the fellow IoTs. And all of you guys, all the fellow IoTs, who has participated to this event, after long hard work at office and come back and attend the session. Then finally, I would like to thank all the volunteers who helped us organizing this event. Without them, I don't think we would be able to make this happen. And thank you guys.
We are about to conclude our event, but before concluding, guys, can we have a big round of applause for our organizers and for our speakers, please? Last but not least, big applause for all IoTers who have gathered here. And guys, please note there will be a few demos by my side. Once the event concludes, if you are interested, you can visit these booths. And before concluding, let me remind, it's not what we do during these few hours. It's about the enthusiasm and the motivation that we would carry forward. So please share your ideas via our Facebook page, Colombo IoT page, and then we do have our web page, colomboiotmeetup.com. Even your criticism, you can share in those web pages as well. So we look forward to see all of you in our next IoT meetup. Until then, thank you everyone. Have a good night.
නෑ නෑ බෑග් එක දාන්න කියලා කොහොමද තිය මේකට දාන්න යන්න දෙන්න මම මාළවෙන්න තමයි මාළව ටිකක් යනවා ඒක සින්න හරි මම ඊයේ බැලුවා මොනවාද අයියුව මේ වීඩියෝ නෑ ෆෝන් ගැත්තේ අර අයියුවනේ අයොනික් අයොනික්කෝ ඩෝලෝ ගැත්තේ මම අයොනික් ඉන්ස්ටෝල් කරලා මේ පොඩි ඇප් එකක් හදන්න try කරලා දෙන ගමන් ඉන්නේ හරි ඒක මම හිතන්නේ ලේසි ඉතන ලොකු අමාරු නෑ ඇංගියුලර් කරපුවා ඇනික් 2 එක එන්නේ ඇංගියුලර් 4 ඇංගියුලර් 2 එකත් එක්ක මම ඇනික් 1 ඩවුන්ලෝඩ් කරේ මේ version 1 2 කියලා නෑ මේ එන ලේටස්ට් එක ඩවුන්ලෝඩ් කරා ඒක ඩිලීට් කරලා ඒක මම මේක version 2 එක මම ඉන්ස්ටෝල් කරන්න බැලුවේ ඒක බෑග් එකේ කිව්වා මේ ඉන්ස්ටෝල් කරලා අයිනික් ඉන්ස්ටෝල් කරද්දී කියන්නේ මම දැන් ඇප් එක අයිය ඉන්ස්ටෝල් කරනවා දැන් මම මොකක් හරි නමක් දීලා ඔව් නේ ඔව් කියලා කියන්නේ එතකොට මම මේ version 2 කියලා හරි එහෙම ඉන්ස්ටෝල් කරන්න බැලුවේ එතකොට ඒක version 2 කියලාද ඔව් බෑග් එක නමක් දෙන්නනේ ඒ කියන්නේ default version 1 වලට install එක අයිනික් ඔව් default install වෙන්නේ latest එක අයිනික් 2 වලට එහෙනම් ඒ කියලා කිව්වේ version 1 වලට නැත්නම් version 2 ම දෙන්න ඕනේ මොන කතාවක් තිබ්බේ අයිනික් කියන්නේ ඔව් ටියුටෝරියල් එක කොහෙන්ද බැලුවේ YouTube මම දන්නවා එයාගේ කියන වැඩ කරා මම version 2 කියලා දෙන්නා මම version 2 නෑ ඔයා දෙන්න බෑ කියලා කිව්වා මොකද්ද යූස් කර ගමන් එක අයිනික් install මුලින්ම blank template version 2 no blank project එහෙනම් මම template එක download කරලා template එක අයිනික් වෙනම install කරා ඔව් මුලින්ම කොඩෝවා download කරා කොඩෝවත් එක්ක අයිනික් කොඩෝවා කියලා දාපුවම එතකොට ඊට පස්සේ අයිනික් එකේ command එකේ අර blank template එකත් project එක install කරන version එක අර එහෙම කරන්න බෑ කොහොමද version එක තුනක් මම install කරා හරි නෑ ඒක පළවෙනිම තමයි මම අයිනික් වන් එකෙන් තමයි ඇක්සස් කරලා දෙනවා කලින් අයිනික් 2 එක ඇංගියුලර් 2 එකත් එක්ක නෑනේ මම හිතන්නේ ඇංගියුලර් 2 එකේ අර TypeScript එක මොකදනා UJS බලුවා UJS එක අර නිකන් ඇංගියුලර් වගේ මේක පොඩ්ඩක් ඒක තේරෙන්නේ අපිට හරි ස්කීමැට් එක යවන්න ඕනේ අපි ස්කීමැට් එක යවලා මොන්නේ පටන් ගන්න තියෙන්නේ අරමු වැඩ ටික කරගෙන යන්න තියෙන ටික කරලා ඊපස්සේ කොහොමත් මේ සතියේ ලබන සතියේ වගේ පටන් ගන්න පුළුවන් වෙයි. මුලින්ම අර මේක හදාගන්න එපා අපි ආකිටෙක්චර් එක හදලා එක යන ඒක කොහොමත් ඇත්ත ගණන් තිබ්බේ වෙබ් ඇප් එකත් එක්ක වෙබ් ඇප් එකත් එක්ක තමයි මොබයිල් එක දෙකම හදන්න තියෙන්නේ. එතකොට REST APIs වලින් තමයි කමියුනිකේට් කරන්නේ. ආ REST API මොකද නේද? මේ කියන්නේ REST API කරන්නේ මොකද? backend ලරවල් හරි ලරවල් වල තමයි මයික්‍රෝ ෆ්‍රේම්වර්ක් එකක් තියෙනවා ලූමන් කියනවා. ලූමන් කියන මයික්‍රෝ ෆ්‍රේම්වර්ක් එක හැබැයි මට හිතෙනවා ලූමන් වලට වඩා ලරවල් එක හොඳයි කියලා. මොකද වෙබ් ඇප්ලිකේෂන් එකකුත් ඕනේ. වෙබ් එකේ හොස්ට් කරලා තියෙන එකකුත් ඕනේ. ඒක තමයි මෙකෙන් data කරන්නේ මොකද? මොබයිල් එක තමයි නිකන් ෆ්‍රන්ට් එකට ක්ලයන්ට්ස් වලට දෙන්නේ. අර මැෂින් එක තිබුණා ලරවල් ටික ගත්තා. හම්බුණා මේ ටියුටෝරියල් එකක් හදන්න chat YouTube හරි අමාරු නෑ හරි අයියේ සජෙස්ට් කරන්න බැරි මට පොඩ්ඩක් මේක තිබුණේ නැද්ද? මැෂින් එකේ තිබුණේ නැද්ද? ලරවල් එකේ තිබුණ Vue.js එක කොහමද මම ලරවල් Vue.js කියලා කෝඩ් එකේ ඒක තිබ්බ chat application එක හොඳයි තමයි. මටත් මාත් ඒක ඒ වගේ තමයි බැලුවේ. ඒකෙන් තමයි බැලුවේ. මගේ ටියුටෝරියල් එකෙන් තමයි අන්තිම ඕක. බලමුට. ඕකේ Vue.js එකේ මට මතක නෑ ඔය මේකේ තිබ්බ එකේ Vue.js tool එක තිබුණා. tool එක එහෙම මතක නෑ. එහෙම තිබුණේ නෑ. ඕඩරේ නම නම් තිබුණා. ඒක දැන් ස්ටේජ් ලරවල් Vue.js. අයියට මටත් මතක නෑ අයියට හම්බුනොත් නිකන් ෆුල් ටියුටෝරියල් එකක් නිකන් ඇප්ලිකේෂන් එක හදනවා වගේ ඒක අයිය සම්පූර්ණ කරලා ගන්න. ෆුල්ලක් හරි ඒක ගැලපෙන්නේ නැත්නම් අයියගේ ස්ටයිල් එක. එතකොට මට අයියට වැඩ කරන්න පුළුවන් නේද? බලමු තව ටික පොඩ්ඩක් හොයලා බලන්න මැෂින් එකේ මට අහුවෙච්ච ඔක්කොම ටික ඕකේ තමයි දැම්මේ. මාත් ඕක කලින් වැඩ කරේ ඕක ගෑවල් මාතේද අර එන්න වෙලාව නැති නිසා කට්ට ගාලා එකයි දාලා තියෙනවා නේද පොඩ්ඩක් බලලා ගන්න ලාරලයි දැන් නෑ කොහොමදයි ඒක වෙනම ඉන්ස්ටෝල් කරන්න ලාරවල් කියන වෙනම ඉන්ස්ටෝල් කරන්න එහෙම ගත්තී ලාරවල් වලින් අපිට පුළුවන් කම්පෝස් එකෙන් ගන්න PHP කම්පෝස් එක දාගන්න කම්පෝස් එකෙන් කම්පෝස් එක දාලා කම්පෝස් එක ගන්න පුළුවන් කියලා එකක් වෙනවා ආයතන කමාන්ඩ් ඔව් ඉන්ස්ටෝල් කරන්න පුළුවන් ඊට පස්සේ ඒකට අපි අදනද නම් ප්‍රොජෙක්ට් එකේම ලාරවල් UC තමයි යනවා ඒවා අන්ලියනේ ඔෆිස් එක ලේසි ඒක කරක් ඔව් සෙකියුරිටි වගේ යාර අපි හදා යනවා ඒක දෙන්න ඕනේ බෑ ඒක පෙන්නන්න ඕනේ ඩෙමෝ එක කොහමද බලමු අපි වල ෂෙඩියුල් එක හරියටම ගාවි අපේ එකක් තියෙනවා මයිල්ස්ටෝන් එහෙම ටාගට් කරලා අපි ඉවර කරලා ප්‍රොජෙක්ට් එක හරියටම ටික දවසක් ගියාම හරියටම ට්‍රැක් එකට ගන්න පුළුවන් ඒ කියන්නේ ටාගට් එක දවසකට ඉවර කරගන්න. අයියගේ අර සයිට් එකේ ප්‍රොනක් ඒව තිබුණේ නැහැ ඒ කියන්නේ ප්‍රොනක් එක සබ්මිට් කරනකොට තව පේජ් එකට යන්නේ ඒව දෙකක් තුනක් විතර මම කරා ඒ විදිහේ ඒක අවුලක් නැහැ ඒක ගන්නේ පුරුයි සයිට් එක ගැන වැඩිලා තියෙනවා ලේසි පුරුස්සල අවුලක් මම අර අයියත් එක දෙන්නට ඒක කියලා හරි සැටර්ඩේ ආයිත් එන්නේ සැටර්ඩේ අයියත් දෙන්නහම අර නෙයි ෆන් සයිට් එකේ තියෙන නිසා තමයි ඒක අර ඉමේජ් වගේ කතා අපි ගත්ත සාමාන්‍ය මොකක් හරි ඒක වාක්‍යයක් තිබුණා ඒක කොහේ තියෙන ඩොට් හතර දැනනවා ඒක මොකක් හරි ඉමේජ් එකක් තියෙනවා ඒක මොකද කරන්නේ අයින් කරන්නේ